Now let's discuss with another important topic, that is calcium. So some important compounds of calcium. So this will be discussing, and this is going to be the last video of this, and this is the most important part. So throughout the chapter will be very energetic, but towards the end of the chapter we lose our enthusiasm, we lose our motivation. But that's why I made a separate video so that we can concentrate on each and every part. So important compounds of calcium are calcium oxide, calcium hydroxide, calcium sulfate, calcium carbonate, and cement. These are industrially important compounds. The large scale preparation of these compounds and their uses are described below. So let's see. Calcium oxide or quicklime, CaO. It is prepared on a commercial scale by heating limestone. Limestone is calcium carbonate in a rotatory kiln at 1070 to 1270 Kelvin. So calcium oxide कैसे बनाना है? सी इंपॉर्टेंट कंपाउंड्स ऑफ कैल्शियम क्या क्या है? कैल्शियम ऑक्साइड, जिसको हम क्या बोलते हैं, क्विक लाइम. कैल्शियम हाइड्रोक्साइड, दैट इज ऑल्सो कॉल्ड स्लेक्ड लाइम. कैल्शियम सल्फेट, कैल्शियम कार्बोनेट, एंड सीमेंट. कैल्शियम कार्बोनेट इज nothing with what? Limestone. Calcium carbonate is nothing but limestone. Calcium sulfate, and we have cement. Cement is also an important compound of calcium. So these are industrially important compounds. The large scale production of these compounds and their uses are described below. So calcium oxide and quicklime. So let's talk about calcium oxide, which is also called quicklime. So we'll make mnemonic or a simple tip or trick to memorize what is calcium oxide. Is it quicklime or slaked lime? What is calcium hydroxide? Slaked lime or quicklime? We get confused, so we'll try to remember this by a trick. So it is prepared on a commercial scale by heating limestone. Limestone is calcium carbonate in a rotatory kiln at 1070 to 1270 Kelvin. So there's a rotatory kiln which rotates, and in that we take limestone, also called marble. So you have to take limestone or marble and you have to heat it. There's a rotatory kiln so that it is heated throughout, and it forms calcium oxide and carbon dioxide. So calcium carbonate is heated to form calcium oxide and carbon dioxide. Calcium oxide and carbon dioxide. Calcium oxide and carbon dioxide. The carbon dioxide is removed as soon as it is produced to enable the reaction to proceed to completion. So the calcium carbonate is removed as soon as carbon dioxide is removed as soon as it is produced to enable the reaction to proceed to completion. Le Chatelet's principle. So you have to remove the calcium, you have to remove what? Carbon dioxide. So that what happens, more and more calcium oxide is formed, and the reaction proceeds to forward direction. Calcium oxide is white amorphous solid. So calcium oxide is a solid, it is white. कैल्शियम के सारे प्रोडक्ट्स वाइट होते हैं. फ्लेम टेस्ट क्या होता है? फ्लेम टेस्ट रेड ब्रिक याद रखना, रेड ब्रिक कलर flame test में. So calcium oxide is white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. So calcium oxide, it is a white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. So calcium oxide is a white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. So calcium oxide is what? It is a white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. So what is calcium oxide? Calcium oxide is white amorphous solid. What is calcium oxide? It is a white amorphous solid. What is calcium oxide? It is a white amorphous solid. So calcium oxide क्या होता है? It is a white amorphous solid. It's white and it is amorphous. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. So calcium oxide plus water. If you add water to calcium oxide, it will form slag lime, calcium hydroxide. Calcium oxide, carbon dioxide, again it will give rise to limestone. Okay, the addition of limited amount of water breaks the lump of lime. This process is called slaking of lime. So if you, what it is amorphous solid, right? It is white and amorphous solid. The addition of limited amount of water breaks the lumps of lime. This process is called slaking of lime. Quick lime slaked with soda gives solid soda lime. So what you have to do, what is calcium oxide? It is solid, amorphous solid, and it is white, and on addition of limited amount of water it breaks the lumps of lime. This process is called slaking of lime. If you add limited amount of water, it breaks the lumps of lime and it forms and this process is called slaking of lime. So quick lime slaked with soda, it gives soda lime, solid soda lime. If it is slaked with soda, if you add a soda to quick lime, then you will get solid soda lime. Being a basic oxide, it combines with acidic oxide at high temperature. So it is a basic oxide because calcium oxide is basic oxide. All except beryllium oxides are basic oxides. Beryllium oxide is beryllium oxides and hydroxides are amphoteric. So being a basic oxide, it combines with acidic oxides. At what? At high temperatures. At high temperature, what happens? At high temperature, being a basic oxide, it combines with acidic oxides at high temperature. So calcium oxide plus silica, SiO2. Silica is sand. So when you mix calcium oxide, means quick lime, with silica SiO2, it will form CaSiO3. It will form what? CaSiO3. CaSiO3. And 6 calcium oxide plus P4O10, it will form 2Ca3PO4 taken twice. 2Ca3PO4 taken twice. So how to do it? Calcium plus 2, right? PO4 P4O10 P4O10, so it will form PO4 minus 3. So 2Ca3PO4 taken twice. Let's talk about its uses. So uses, let's see uses. So its uses is, you can see here uses. It is an amphoteric primary material for manufacturing cement. For manufacturing cement, important primary material is calcium oxide, quick lime, and it's cheapest form of alkali. So you want to manufacture cement, now you want to build a company of cement, and to build a company of cement you need a main important primary material. So what will be that? That will be calcium oxide, and this calcium oxide is the cheapest form of alkali, and it's the cheapest form of alkali. It is used in the manufacture of sodium carbonate. It is used in the manufacture of sodium carbonate, Na2CO3, from caustic soda. So in alkali metals, you might have learned that caustic soda, for the preparation of the manufacture of sodium carbonate from caustic soda. Caustic soda is sodium hydroxide. Sodium hydroxide is sodium hydroxide and calcium oxide. They are used in the manufacture of sodium carbonate, Na2CO3. That is baking soda. Okay. So it is employed in the purification of sugar and the manufacture of dyestuffs. So purification of sugar and the manufacture of dyestuffs. So purification of sugar in the manufacture of dyestuffs. So in the manufacture of dyestuffs, the purification of sugars, we use calcium oxide. So if you can relate somewhat to surface chemistry. So जो अपना कैल्शियम ऑक्साइड है, it is used in the preparation or purification of sugars. Purification of sugars में कौन you have to purify sugar. So to purify sugar you need calcium oxide also you can use. Basically in surface chemistry we have seen that charcoal is used in the purification of sugars to get white crystalline sugars. So you can also use calcium oxide. In the manufacture of dye stuffs also calcium oxide is used. It is used in the manufacture of sodium carbonate from caustic soda. So sodium carbonate from caustic soda, it is what is used? Calcium oxide is used in the preparation of sodium carbonate from caustic soda. Sodium carbonate from caustic soda. Sodium carbonate from caustic soda. sodium carbonate from caustic soda, in that calcium oxide is used. In that calcium oxide is used. तो अगर आपको caustic soda बनाना है, sorry, if you want to prepare what, if you want to prepare sodium carbonate from caustic soda, so you can use calcium oxide. So sodium carbonate from caustic soda, it is employed in the purification of sugar and the manufacture of dyestuffs. It is employed in the purification of sugar. If you want to purify sugar, the manufacture of dyestuffs, purification of sugar, dyestuffs. So calcium oxide is what? White in color. So how do we remember all these uses? And then again we have to remember the uses of calcium hydroxide and calcium carbonate, calcium sulfate, and we get confused. So let's do. So calcium oxide is white and it is amorphous solid. This you remember one thing. Another thing is, from a calcium oxide you can prepare calcium hydroxide. From calcium hydroxide you can prepare other compounds. Okay, so if you want to cement, manufacturing of cement, so the primary material and the cheapest form of alkali is calcium oxide. It is used in the manufacture of sodium carbonate from caustic soda. It is used in the manufacture of sodium carbonate from caustic soda. So you want to prepare sodium carbonate, baking soda, it is also white in color, so you can use calcium oxide. Purification of sugar, you want white sugar, you can use calcium oxide. Manufacture of dyestuffs, you want dyes, you can use calcium oxide. Now let's talk about white color. You have to remember, so purification of sugar, you want to get white sugar, so calcium oxide you can use. Dyestuffs, calcium oxide you can use to get colors, right? White color is used. Yeah. The manufacture of baking soda, which is white in color. Sodium carbonate is nothing but baking soda, right? From caustic soda, you have to prepare caustic soda, is also white in color. It is an important primary material if you want cement, which is not white in color, but yeah, you can use, it is grey in colors. For that you can use calcium oxide. Calcium hydroxide, slaked lime, calcium hydroxide. Calcium hydroxide is prepared by adding water to quick lime, calcium oxide. So calcium hydroxide is prepared by adding water to quick lime. Add water to quick lime, you will get calcium hydroxide. So it is white amorphous powder. That was solid, this is powder. So it is white amorphous powder. It is sparingly soluble in water. So calcium hydroxide is white amorphous powder. It is sparingly soluble in water. Sparingly soluble in water means it's not that much soluble. The aqueous solution is known as lime water. So if you take aqueous solution of this, because it is in the form of powder, and if you take aqueous solution, this is called lime water. And a suspension of slaked lime in water is known as milk of lime. If you're taking large amounts in water, then it is called milk of lime, which is white in color, creamy and white in color. Don't test it. So when carbon dioxide is passed through lime water, it turns milky due to the formation of calcium carbonate. So when carbon dioxide, you have to take carbon dioxide is passed through lime water. You have to take carbon dioxide is passed through lime water, then it turns milky white due to the formation of calcium carbonate. Calcium carbonate. So calcium hydroxide you have to take in carbon dioxide, so we'll get calcium carbonate plus water, so which is milky due to the formation of calcium carbonate is formed. So it is milky in color. So when you pass carbon dioxide in the slaked lime, it will form calcium carbonate and water. So on passing excess of carbon dioxide, the precipitate dissolves to form calcium hydrogen carbonate. On passing excess of carbon dioxide, if you pass excess of carbon dioxide, it precipitates to form calcium hydrogen carbonate. Okay, so calcium carbonate plus carbon dioxide plus water, it will form calcium hydrogen carbonate, bicarbonate. Milk, if you pass excess of carbon dioxide, the calcium carbonate that is formed, it will react with carbon dioxide. Milk of lime reacts with chlorine to form hypochlorite. Milk of lime, this is nothing but COH taken twice. It reacts with chlorine. Chlorine, a constituent of bleaching powder, is formed, that is hypochlorite. Hypochlorite is formed. So what is bleaching powder? Bleaching powder. Bleaching powder का component, that is Ca. What is the bleaching powder component? CaOCl taken twice. CaOCl taken twice. CaOCl taken twice. CaOCl taken twice. So if you see bleaching powder, you know, baking soda. Baking soda is bicarbonate, sodium bicarbonate. Sodium carbonate and 10 water molecules will form washing soda. Washing soda. That will form washing soda. Washing soda is decahydrate. 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 Sodium carbonate, decahydrate. And caustic soda is sodium hydroxide. Sodium chloride, NaCl, of course. And sodium hydrogen carbonate is nothing but baking soda. Baking soda. Sodium bicarbonate is baking soda. So bicarbonates are formed by passing excess of carbon dioxide to carbonates. Similarly, here also if you pass excess of carbon dioxide, it will form calcium hydrogen carbonate. Calcium hydrogen carbonate. So what is bleaching powder? So bleaching powder का एक component होता है CaOCl taken twice. CaOCl taken twice. CaCl2 plus CaOCl taken twice plus 2 water molecules. CaCl2 plus CaOCl taken twice plus 2 water. Uses. It is used in the preparation of mortar, a building material. It is used in the preparation of mortar. It is used in the preparation of mortar, a building material. It is used in the preparation of mortar. It is used in the preparation of mortar, a building material. So it is used in the preparation of mortar, a building material. तो मोटर बनाना है आपको, मोटर बनाना है तो मोटर बनाने के लिए क्या करना है? कैल्शियम हाइड्रोक्साइड लेंगे. Building material. It is used in whitewash due to its disinfectant nature. So you know, whitewash. These days also walls are painted with this slaked lime because it is having disinfectant property, and it's white in color, and it is cheaper. So many people use this to paint their houses. So some whitewash. It is used in glass making. So it is glass making, in tanning industry, for the preparation of bleaching powder and purification of sugar. Since it is used in the bleaching powder, you can use in glass making, tanning industry, and purification of sugars. Here also you can use purification of sugar. Mortar, building materials, whitewash, and because it acts as disinfectant. So this is one more general thing, that in olden days there were no that much advanced cosmetics, so the actors and models, they were used to be under whitewash. Their faces, their bodies were painted with whitewash so they look good. Nowadays we have cosmetics. Okay, calcium carbonate, CaCO3. Calcium carbonate occurs in nature in several forms like limestone, chalk, marble, etc. It can be prepared by passing carbon dioxide through slaked lime or by addition of sodium carbonate to calcium carbonate, or by addition of sodium carbonate to calcium chloride. So two reactions you have to remember for the preparation of limestone or marble. CO is taken twice plus carbon dioxide, CaCO3 plus water. CaCl2 plus Na2CO3. It will form CaCO3 plus 2 NaCl. 2 NaCl. So CaCO3 plus 2 NaCl. So you will get what? Calcium carbonate. Excess of carbon dioxide. Excess of carbon dioxide should be avoided, since this will lead to the formation of water soluble calcium bicarbonate. So calcium bicarbonate is water soluble. See, in hydrogen and its compound, we have seen that the hardness of water is due to what? Comment below before I say the answer. So pause the video and go and comment in this comment the answer. So the hardness of water is due to four things. What are that? What are that? Four things. Hardness of water is due to four things, like four chemical compounds. So the hardness of water is due to calcium and magnesium carbonates or bicarbonates. Calcium or sodium carbonates or calcium and magnesium carbonates or bicarbonates. Temporary hardness is due to presence of calcium and magnesium hydrogen carbonates, that is bicarbonates. Calcium and magnesium bicarbonates. Calcium and magnesium bicarbonates. So excess of carbon dioxide that is temporary hardness, of course. Excess of carbon dioxide should be avoided, since this lead to the formation of water soluble calcium hydrogen carbonate. Calcium hydrogen carbonate. So these are soluble. Calcium and magnesium bicarbonates are soluble, or hydrogen carbonates are soluble, so they cause temporary hardness to the water. And permanent hardness is due to the calcium and magnesium chlorides and sulfates. So soluble salt se pareshani hai. The salts that are insoluble, we don't have problem with that, but these are soluble. Magnesium and calcium, chlorides and sulfates, these are soluble in water. Since we know why they are soluble in water, we have discussed in very detail that calcium and magnesium carbonates, down the group of sulfates and carbonates, down the group, what happens, the solubility decreases because the lattice energy increases and hydration enthalpy decreases. But the initial sodium sulfates and carbonates, they are soluble in water because the hydration energy is more and lattice enthalpy is not that much more. Okay, let's talk about calcium carbonate. Is a white fluffy powder. So it's a white fluffy powder. It is also white powder. It is almost insoluble in water. We don't have problem with calcium carbonate. We have problem with calcium bicarbonates, calcium hydrogen carbonates and magnesium carbonates, which cause temporary hardness. And you can remove the temporary hardness through Clark's method, right? By adding lime. Yeah, of course, by adding lime. By adding what? By adding lime. So when heated, calcium carbonate is white fluffy powder. It is almost insoluble in water. When heated to 1200 Kelvin, it decomposes to evolve carbon dioxide. So when you heat it, then what happens? It will form release carbon dioxide and it will form calcium oxide. Calcium oxide is what? Quicklime. So vice versa, we were decomposing in rotating kiln about 1200 Kelvin. One more thing about 1200 Kelvin is above this temperature, what happens? At this temperature, beryllium chloride, which are in vapors in the vapor form, which are in the form of chlorobrist dimer, they dissociate and become linear monomer at 1200 Kelvin order, right? Yeah. In Clark's method, what we do, we take hard water, and we can remove its temporary hardness by treating the water with, the water is having calcium and magnesium bicarbonates, right? We can treat it with the calcium hydroxide, that is slagged lime, this lime. Okay, we can treat it with lime, and it will form calcium carbonate, and calcium carbonate will precipitate because it is insoluble in water. So it will precipitate, right? Similarly, for calcium carbonate we can form, and calcium carbonate and water will form, right? So this reaction is also important. We can correlate because ऐसा थोड़ी ना होता है, chapter wise test थोड़ी ना होता है. In NEET you will, in NEET or CBSE you have full syllabus test, right? Full syllabus. So they compare, they correlate few things and they frame the questions, right? So the calcium bicarbonate and magnesium bicarbonate, you can treat it with lime, CaOH taken twice, and form calcium carbonate and water. You can remember this reaction. It will help you a lot. So calcium carbonate को 1200 केल्विन पे ट्रीट करने से कैल्शियम ऑक्साइड कार्बन डाइऑक्साइड बनता है. इट रिएक्ट्स विद डाइल्यूट एसिड टू लिबरेट कार्बन डाइऑक्साइड. सो कैल्शियम कार्बोनेट इट रिएक्ट्स विद डाइल्यूट एसिड. जैसे कैल्शियम कार्बोनेट है उसको डाइल्यूट एसिड से ट्रीट करो तो कैल्शियम क्लोराइड और वाटर और कार्बन डाइऑक्साइड बन जाएगा. सो इफ़ यू वांट कार्बन डाइऑक्साइड बैक, if you want carbon dioxide, CaCl2 will form and carbon dioxide will release in water also. So calcium carbonate plus H2SO4, CaSO4, water and carbon dioxide again. Let's talk about uses. So it is used in the building material in the form of marble. Marble है, and you know marble is very useful in building. And the manufacture of quicklime. Quicklime we have seen by thermal decomposition of this calcium carbonate we were getting. What rotatory kiln we were taking. Calcium carbonate along with magnesium carbonate is used as a flux. Calcium carbonate along with magnesium carbonate is used as a flux. As a flux. As a flux. So calcium carbonate जो है, calcium carbonate. So calcium carbonate is used as calcium carbonate के साथ साथ जो magnesium carbonate है, it is used as a slag. It is used as what? It is used as a slag in the extraction of iron. तो if you check NCERT of metallurgy, वहाँ पे देखें limestone. Limestone is used as a slag for removing sulfur, silicon and phosphorus. So ये NCERT में देखें, you can open your NCERT and check it out. So for the extraction of जब ब्लास्ट फर्नेस से हमें आयरन मिलता है उसमें भी थोड़े इम्प्यूरिटीज़ होते हैं. तो wrought iron is the commercial iron, right? It is the most purest form of iron. तो वो आयरन बनाने के लिए we have to we want pure iron. So the impurities can be removed by using limestone as a basic slag, right? So specially precipitated calcium carbonate is extensively used in the manufacture of high quality paper. If you want high quality paper, specially prepared precipitated calcium carbonate is extensively used in the manufacture of high quality paper. Like classmate के papers high quality होते, classmate books. So for preparing high quality papers, specially precipitated calcium carbonate use होता है. It is used as an antacid, mild abrasive in toothpaste. इससे पहले हमने डिस्कस किया था मैग्नीशियम कार्बोनेट के बारे में, which is a component of toothpaste, an ingredient of toothpaste. तो मैंने बताया कि नीट एस्पिरेंट्स के लिए उनके टूथपेस्ट में नमक नहीं, कि टूथपेस्ट में कैल्शियम मैग्नीशियम कार्बोनेट होता है. और माइल्ड एब्रेसिव मतलब आपके दांतों को ख़राब होने से बचाने के लिए माइल्ड एब्रेसिव की तरह इसमें लाइमस्टोन पत्थर भी मिला देते हैं. एंड कॉस्मेटिक्स में पता है एज अ फिलर इन कॉस्मेटिक्स कैल्शियम कार्बोनेट. तो फिलर इन कॉस्मेटिक्स में अभी भी कैल्शियम कार्बोनेट यूज़ होता है एज a filler. So mild abrasive in toothpaste, chewing gum is a constituent of chewing gum also. Okay, let's talk about antacid की तरह भी यूज़ होता है. कैल्शियम सल्फेट विच इज़ प्लास्टर ऑफ पेरिस. सो पेरिस में अगर आप इट्स जस्ट अ ट्रिक. सो कैल्शियम सल्फेट हेमीहाइड्रेट होता है. कैल्शियम सल्फेट हेमीहाइड्रेट होता है. हाउ टू रिमेंबर दैट? जो कैल्शियम सल्फेट होता है वो हेमीहाइड्रेट होता है. हाउ डू वी रिमेंबर दैट? जो कैल्शियम सल्फेट होता है वह हेमीहाइड्रेट होता है बिकॉज इफ़ यू गो टू पेरिस विल गेट हाफ वाटर बॉटल. इफ़ यू गो टू पेरिस फुल वाटर बॉटल नहीं मिलेगा आपको, हाफ वाटर बॉटल मिलेगा. सो कैल्शियम सल्फेट इज हैविंग a half water molecule, that is hemihydrate. So it is a hemihydrate of calcium sulfate. It is obtained when gypsum is CaSO4 2H2. Sum means 1 + 1 2. So CaSO4 में कितने 2 water molecules और प्लस पेरिस में प्लास्टर ऑफ पेरिस में हाफ वाटर मॉलिक्यूल फॉर 1 कैल्शियम कार्बन सल्फेट. उसके बाद इफ़ gypsum is heated to 393 Kelvin then you will get plaster of Paris. And how do you remember all temperatures and all? So it's a simple 393 Kelvin. इसका मतलब आप 393 केल्विन में। तो फर्स्ट बार हीट करोगे तो CaSO4 2H2, फर्स्ट 100 केल्विन पे क्या होगा, CaSO4 1/2H2, फिर से एक बार CaSO4 1H2, फिर से एक बार CaSO4 1/2H2, मीन्स 3 टाइम्स, तो 393 केल्विन. It's very near to 400 Kelvin. So if you heat above 393 Kelvin, no water of crystallization is left, and anhydrous calcium sulfate, CaSO4 is formed. CaSO4 is anhydrous calcium sulfate, which is known as dead burnt plaster. It has a remarkable property of setting with water. On mixing with an adequate quantity of water, it forms a plastic mass that gets into a hard solid in 5 to 15 minutes. Now let's talk about uses. The largest use of plaster of Paris is in the building industry as well as plasters. The largest use of plaster of Paris is in the building industry as well as plasters. It is used for immobilizing the affected part of organ where there is a bone fracture or sprain. Uses क्या है? So the largest use of plaster of Paris pop is in the building industry as well as plasters. It is used for immobilizing the affected part of organ where there is a bone fracture or sprain. So when there is a bone fracture or a sprain, see, bone fracture or sprain, what happens when there is a bone fracture? The bones should not be disturbed so that there can be so it can be healed properly. So for immobilizing that affected organ, then what happens? Plaster of Paris is used to keep it in the place for so that it do not mobilize, it cannot move. Okay, it is also used in dentistry, in ornamental work, and for making cast of statues and busts. For making statues also plaster of Paris is used. For making false ceiling also plaster of Paris is used. For making ornamental works also plaster of Paris is used. Cement is an important building material. What is cement? Cement is an important building material. Let's discuss the story of cement. So cement is an important building material. We know that for building a house, a building, a bungalow, office, anything, we need cement, right? It was first introduced in England. So cement first came from England in 1824 by Joseph Aspdin. He introduced cement in England. Why it is also called a Portland cement? Why? Because uh, uh, it resembles with the natural limestone. Quarried in the Islay of Portland, England. So it resembles with natural limestone. So that's why it was named Portland cement. Portland is nothing but a place in England where limestone, natural limestone was there, and this natural limestone is resembling with the cement, so that's why it was named Portland cement. It was introduced in England for the first time. And cement is a product obtained by combining a material rich in lime. What is lime? CaO. मैंने बोला था कि CO is the primary material for the manufacture of cement. So it is rich in lime. So cement is a product obtained by combining a material rich in lime, CO, with other materials such as clay. With other materials such as clay. So it is mainly formed from calcium oxide. That is also called quicklime. The quicklime is calcium oxide. So quicklime से बना है ये. Okay. Another thing is जो अपना cement है, it contains CaO, quicklime, lime, clay, and silica. Silica is SiO2 along with the oxides of aluminium, iron, and magnesium. So cement में क्या क्या होता है? Cement is a product obtained by combining a material rich in lime, CO, with other materials such as clay, which contains silica. Clay contains silica, right? Silica along with the oxides of aluminium, iron, and magnesium. तो क्या क्या होता है? मटेरियल लेना है जिसमें बहुत ज़्यादा कैल्शियम ऑक्साइड मीन्स क्विक लाइम होता है, लाइम होता है, एंड क्ले इज़ रिच इन सिलिकॉन डाइऑक्साइड SiO2। और दूसरी बात है कि जो कैल्शियम ऑक्साइड है वो है सैंड और क्ले सिलिका है, एंड ऑक्साइड्स ऑफ एल्यूमिनियम, मैग्नीशियम और आयरन का भी ऑक्साइड है। तो सीमेंट बहुत हार्ड होता है क्योंकि उसमें मेटल्स हैं जैसे एल्यूमिनियम, मैग्नीशियम एंड आयरन। तो आयरन का भी मेटल है, इसलिए सीमेंट बहुत स्ट्रॉन्ग होता है। सो किसके किसके ऑक्साइड्स होता है, सिलिका सिलिका होता है, क्ले से मिलता है, और कैल्शियम ऑक्साइड होता है, या फिर कोई भी जिसमें कैल्शियम ऑक्साइड रिच है। और अनदर थिंग इज़ पहली बार सीमेंट इंट्रोड्यूस कहाँ हुआ था, पहली बार इंग्लैंड में हुआ था, है ना। सीमेंट पहली बार कहाँ इंट्रोड्यूस हुआ था, इंग्लैंड में। एंड अब अगर थोड़ा सा रिलेट करें, जब इंग्लैंड में सीमेंट आया था तो उसके बहुत सारे यूजेस हुए होंगे, बहुत सारा यूज़ किया गया होगा सीमेंट को। जब बहुत सारा सीमेंट को यूज़ किया, देन व्हाट हैपेंड, पोल्यूशन हुआ। और कब इंट्रोड्यूस हुआ था, इन द ईयर 1824, और 1850s तक उतना इस्तेमाल नहीं हुआ था। उसके बाद इंडस्ट्रियलाइजेशन होने लगा, उसके बाद बहुत ज़्यादा यूज़ हुआ। सो मैं थोड़ा सा अगर रिलेट करूँ तो यू कैन रिलेट इट विथ evolution. If you see natural selection another interesting observation supporting evolution by natural selection comes from England. वो अलग एग्जाम्पल, मौत का, वाइट मौत, डार्क मौत, मेलानिज्म, इंडस्ट्रियल मेलानिज्म। सो इंग्लैंड में हुआ था, इंग्लैंड में पोर्टलैंड सीमेंट में निकला था, राइट। सो बिफोर इंडस्ट्रियलाइजेशन वाइट मॉथ्स ज़्यादा थे ऑन ट्रीज देन डार्क मॉथ्स। एक सेकेंड, इट वॉज ऑब्जर्व दैट देयर वर मोर वाइट मॉथ्स ज़्यादा थे, और डार्क मॉथ्स क्या थे, डार्क मॉथ्स पूरे पूरे लाइक prey like predators will eat the dark moths because they were visible. But after industrialization there was a lot of dust, pollution, so that what happened, the bark of the trees became black, and then dark moths were getting mimicking that, and like same color है, तो इसकी वजह से जो डार्क मॉथ्स हैं वो अनआइडेंटिफाइड रहते थे प्रीडेटर्स से, और जो वाइट मॉथ्स हैं वो प्रीडेटर्स कंज्यूम कर लेते थे। ओके, सो उसके बाद इंडस्ट्रियलाइजेशन के बाद डार्क मॉथ्स ज़्यादा हो गए एंड वाइट मॉथ्स कम हो गए। सो दैट वाज एन एग्जांपल of melanism, that is from biology point of view. But if you're a JEE aspirant, so you don't need to do, but I just related it with यहाँ पे सीमेंट इंग्लैंड से आया था और इंग्लैंड में इंडस्ट्रियल मेलानिज्म हुआ था। Okay, cement is a product obtained by combining a material rich in lime. So cement is a product obtained by combining material rich in lime, CO, with other materials such as clay, which contains silica, SiO2, along with the oxides of aluminium, iron and magnesium. The average composition of Portland cement is कैल्शियम ऑक्साइड सबसे ज़्यादा होता है। कितना होता है, ज़्यादा होता है मतलब 50 to 60% होता है, 50 to 60% होता है। 50 to 60% सिर्फ और सिर्फ कैल्शियम ऑक्साइड होता है। तो मैं बोल सकती हूँ मेन प्राइमरी मटेरियल है ना। सो कैल्शियम ऑक्साइड बहुत ज़्यादा होता है, 50 to 60%। फिर सिलिका जो क्ले से भी मिलता है, दैट इज़ 20 to 25%। कितना, 20 to 25%, 20 to 25%, 20 to 25%। और एलुमिना Al2O3 5 to 10%, 5 to 10%। एलुमिना कितना होता है, 5 to 10%। MgO 2 to 3%, MgO मैग्नीशियम ऑक्साइड 2 to 3%, एल्यूमिनियम ऑक्साइड 5 to 10%, आयरन ऑक्साइड 1 to 2%, SO3 1 to 2%। सो ये होता है, ये आपको ना लिख कर पेस्ट कर लेना है। तो फिर भी मैं एक रफ स्केच देती हूँ कैसे याद रखना है। कैल्शियम ऑक्साइड मेजर होता है, मेजर मतलब 50% तक, 50 to 60%। अब SiO2 मतलब मट्टी, सैंड कितना होगा, 20 to 25%, सिर्फ 20 to 25%। फिर एलुमिना एल्यूमिनियम ऑक्साइड 5 to 10%, मैग्नीशियम ऑक्साइड 2 to 3%, फिर आयरन ऑक्साइड 1 to 2%, SO3 1 to 2%, 1 to 2 2 to 3, फिर 4 गया, 5 to 10, 20 to 25, 50 to 60. सो लोहा सिर्फ 1 to 2% होता है. फॉर अ गुड क्वालिटी सीमेंट, द रेशियो ऑफ सिलिका टू एल्यूमिना शुड बी बिटवीन 2.5 to 4, बिटवीन 2.5 and 4 के बीच में. फॉर गुड क्वालिटी सीमेंट परसेंटेज ऑफ सीमेंट कितना होना चाहिए. तो ये बहुत कंजस्टेड दे दिया है, तो इसको अलग से लिखते हैं. फॉर अ गुड क्वालिटी सीमेंट, गुड क्वालिटी सीमेंट गुड क्वालिटी सीमेंट कितना. गुड क्वालिटी सीमेंट का रेशियो कितना होता है. गुड क्वालिटी सीमेंट कितना होता है. गुड क्वालिटी सीमेंट का रेशियो एल्यूमिना और सिलिका एंड एल्यूमिना का रेशियो, सिलिका एंड एल्यूमिना का रेशियो, परसेंटेज रेशियो 2.5 to कितना 4.5 के बीच में होना चाहिए. 2.5 and 4.5 के बीच में कितना 2.5 एंड 4 के बीच में. तो ये याद रखना 2.5 to 4. सिलिका कितना होता है 20 to 25%, एल्यूमिना 5 to 10%. तो इनके 2.5 एंड 4 के बीच में होना चाहिए. इसका मतलब सिलिका ज़्यादा होना चाहिए, एल्यूमिना कम होना चाहिए, 2.5 and 4%. Okay, now next let's see, that is it should be between 2.5 and 4, and the ratio of lime CaO to the total of the oxides of silicon SiO2. So and the ratio of lime क्या है CaO to the total of the oxides of silicon SiO2, aluminium Al2O3, iron Fe2O3 should be as close as possible to 2. Ratio of lime CaO and the total oxides of silicon SiO2, aluminum oxide, iron oxide should be as close to 2. So रेशियो किसका, कैल्शियम ऑक्साइड लाइम का, एंड रेशियो ऑफ ऑल द ऑक्साइड, सिलिका ऑक्साइड, एल्यूमिना ऑक्साइड, एल्यूमिनियम ऑक्साइड, आयरन ऑक्साइड कौन सा है Fe2O3 ले रहे हैं हम, Fe2O3. तो कितना होना चाहिए 2 तक होना चाहिए, 2 फॉर अ गुड सीमेंट. द रॉ मटेरियल्स फॉर द मैन्युफैक्चर ऑफ सीमेंट आर लाइमस्टोन एंड क्ले. द रॉ मटेरियल्स फॉर द मैन्युफैक्चर ऑफ सीमेंट आर लाइमस्टोन एंड क्ले. सीमेंट बनाने के लिए एक लाइमस्टोन चाहिए, लाइमस्टोन से हम कैल्शियम ऑक्साइड बना लेंगे, एंड क्ले. When clay and lime are strongly heated together, they fuse and react to form cement clinker. When clay and lime are strongly heated, they fuse and react to form cement clinker. So tell me, what is cement clinker? Cement clinker क्या होता है? When clay and lime are strongly heated together, they fuse and react to form cement clinker. This clinker is mixed with 2 to 3% by weight of gypsum CaSO4 some to form cement. So जब clay and lime strongly heat करना उसको, तो they fuse to form cement clinker. Clinker is mixed with 2 to 3% by weight of gypsum to form cement. The important ingredients present in Portland cement are dicalcium silicates CaSiO4 26%. तो रॉ मटेरियल्स सीमेंट बनाने के लिए मेन थिंग है लाइमस्टोन और एक है क्ले. लाइमस्टोन प्रोवाइड्स CaO, right? Clay provides Al2O3, SiO2, gypsum CaSO4 So this is the raw materials. So when clay and lime are strongly heated, they fuse and form cement clinker. This clinker is mixed with 2 to 3% by weight of gypsum. सिर्फ कितना 2 to 3% gypsum to form cement. Thus important ingredients present in Portland cement are dicalcium silicates CaSiO4 26%, tricalcium silicate Ca3SiO5 51%, and tricalcium aluminate Ca3L2O6 11%. So cement clinker is when you heat lime and silica, clay, lime and clay, you get cement clinker, and then you have to add 2 to 3% by weight of gypsum also. This gypsum CSO4 2H2, so you'll get cement. The important ingredient present in Portland cement are dicalcium silicate, that is CaSiO4, that is 26%, tricalcium silicate Ca3SiO5 51%, and tricalcium silicate aluminum silicate, that is Ca3L2O6. So all are like dicalcium silicate, and remaining tricalcium silicate, and that is 51%, and tricalcium aluminate, that is only 11%. So tricalcium silicate is 3CaOSiO2, or you can say Ca3SiO5, which is 51%. Dicalcium is only 26%, and aluminate is 11%. Tetracalcium aluminoferrate is 4CaO L2O3 Fe2O3. So cement is calcium aluminates and silicates. It is an important building material, its uses. Setting of cement. When mixed with water, the setting of cement takes place to give a hard mass. This is due to the hydration. Only 20 to 25% silica is there, and we are adding 2 to 3% gypsum only. Why? Let's see. The setting of cement. When mixed with water, the setting of cement takes place to give a hard mass. This is due to the hydration of the molecules of the constituents and their rearrangement. This is due to the hydration of molecules in the constituents and their rearrangement. The purpose of adding gypsum is only to slow down the process of setting of the cement so that it gets sufficiently hardened. So rearrangement will take place in the constituent molecules, and then hydration of molecules takes place. The purpose of adding gypsum is only to slow down the process of setting of cement so that it gets sufficiently hardened. Uses. Calcium silicates are added, right? Uses. Cement has become a commodity of national necessity for any country next to iron and steel. It is used in concrete and reinforced concrete, in plastering and in the construction of bridges, dams, buildings. Concrete and reinforcing concrete, plastering, the construction of bridges, dams, buildings, construction of everything. Biological importance of magnesium and calcium. An adult body contains about 25 gram of magnesium and 1200 gram of calcium, compared with only 5 grams of iron and 0.06 gram of copper. The daily requirement in the human body has been estimated to be 200 to 300 mg. So an adult body contains about 25 grams of magnesium and 12 grams of calcium. So an adult body contains about 25 grams of magnesium. An adult body contains about 25 grams of calcium and 12 grams of calcium. An adult body contains about 25 grams of magnesium. कितना magnesium? 25. Calcium 1200 grams. Calcium ज़्यादा होता है. Human body में sodium ज़्यादा है, potassium? Comment below. That is, potassium is more. Compared with 5 grams of iron. So if we talk about hemoglobin, that is 12 to 16 grams of hemoglobin. उसमें से 5 grams of iron and 0.06 gram of copper. The daily requirement in the human body has been estimated to be 200 to 300 mg. Milligrams, right? Okay. All the enzymes that utilize ATP in phosphate transfer require magnesium. So magnesium is the activator of ATP. Means if you want ATP, all the enzymes that utilize ATP in phosphate transfer require magnesium as the cofactor. The cofactor of enzymes that utilize ATP is magnesium. So human body requirement of calcium in a day is 200 to 300 mg. Calcium कितना चाहिए? 200 to 300 milligrams कैल्शियम चाहिए. You should consume 200 to 300 milligrams. All enzymes that utilize ATP in phosphate transfer require magnesium as the cofactor. The main pigment for the absorption of light in chlorophyll is chlorophyll, which contains magnesium. Magnesium form complex in chlorophyll. About 99% of body calcium present in bones and teeth. It also plays important role in neuromuscular junction. जैसे हमने if you are a biologist and you might be knowing that न्यूरोमस्कुलर जंक्शन में कैल्शियम कितना इंपॉर्टेंट रोल प्ले करता है. एंड इफ यूर बायोलॉजी स्टूडेंट, आई हैव अ क्वेश्चन फॉर यू दैट इज in muscles, in skeletal muscles, or striated muscles, which part of the cell or which cell organelle of the muscle cell stores calcium? Comment below. So it also plays important role in neuromuscular junction, interneuronal transmission, cell membrane integrity, blood coagulation. So interneuronal transmission, interneuronal ओके ठीक है. तो अगर आप बायोलॉजी के स्टूडेंट्स नहीं हैं तो इट्स वेरी इंपॉर्टेंट टू नो दैट न्यूरोमस्कुलर फंक्शन में हेल्प करता है. अगर आपको कोई भी मूवमेंट करना है तो आपको कैल्शियम रिक्वायरमेंट होगा. और कैल्शियम बहुत इंपॉर्टेंट रोल प्ले करता है आपको मूवमेंट करने में. अगर आपकी बॉडी में कैल्शियम की कमी हो गई तो आप तो द डिजीज़ दैट इज़ दैट अकर्स इज़ कॉल्ड, डिजीज़ को क्या बोलते हैं बायोलॉजी स्टूडेंट्स? कमेंट बिलो सो दैट यू. तो वो डिजीज़ को हम सो द टू टाइप्स ऑफ डिजीजेस. लेकिन जो कैल्शियम की कमी की वजह से होती है उसका नाम है टेटानी. उसका नाम है टेटानी. सो मैं कोई बुक में से देख के नहीं बोल रही. आई हैव मेमोराइज्ड इट. आई एम अ बायोलॉजिस्ट एंड सो आई नो दिस. सो इंटरन्यूरोनल ट्रांसमिशन जो है उसमें भी हेल्प करता है. कैल्शियम सेल मेम्ब्रेन इंटीग्रिटी में, ब्लड कोआगुलेशन में कैल्शियम यूज़ करता है. द कैल्शियम कॉन्सेंट्रेशन इन प्लाज्मा इज रेगुलेटेड अबाउट 100 milligrams per liter. इट इज़ मेंटेन बाय टू हार्मोन्स. वन इज़ कैल्सिटोनिन एंड इज़ पैराथायरॉइड हार्मोन. इसका फंक्शन बता देता है. तो कैल्सिटोनिन क्या करता है, जो आपके बोन्स हैं उसमें कैल्शियम डिपॉजिट करता है. ब्लड में जो कैल्शियम है उसको बोन पे डिपॉजिट करता है. जब ब्लड में कैल्शियम ज़्यादा हो जाता है तो वो ब्लड में से कैल्शियम लेके बोन में डिपॉजिट करता है. दूसरा है पैराथायरॉइड हार्मोन, जो एकदम एंटागोनिस्टिक है इसके. वो जब ब्लड में कैल्शियम की कमी होती है, क्योंकि कैल्शियम इज़ रिक्वायर्ड फॉर मसल कॉन्ट्रैक्शन, राइट. और मसल कॉन्ट्रैक्शन में हेल्प करता है कैल्शियम. हेल्प क्या, वही मेन इंपॉर्टेंट रोल प्ले करता है. तो इसलिए वो बोन से क्या करता है, कैल्शियम निकाल के ब्लड में डाल देता है. तो दैट इज़ पैराथायरॉइड. तो बहुत एंटागोनिस्टिक है. यहाँ से एक बायोलॉजी का क्वेश्चन बन रहा है. डू यू नो दैट बोन इज़ नॉट एन इनर्ट एंड अनचेंजिंग सब्सटेंस बट इट कंटिन्यूसली बीइंग सॉल्युबलाइज्ड एंड रीडिपॉजिटेड. सॉल्युबलाइज्ड किसकी वजह से हो रहा है, पैराथायरॉइड. और रीडिपॉजिटेड बिकॉज ऑफ कैल्सिटोनिन टू द एक्सटेंट ऑफ 400 milligrams per day in man. All these calcium passes through the plasma. So सब कैल्शियम प्लाज्मा में होता है, passes through the plasma. So by this we have completed successfully whole alkaline earth metals with simple tricks and tips and all everything we have done. So thank you so much.